Okay, so look at this question. A continuous random variable y have probability density function, so small f here, and then look at your function involving modulus. So in your piecewise function, still involving modulus, you have to define your modulus function first, so that in the interval will be more accurate. From 0 to 2 is m. From 2 to 5, here we have a piecewise function as modulus y minus 3 can be expressed in piecewise. It will be positive when it greater equals to 0. It will be negative when this function less than 0. So after we simplify, it will be y minus 3 when y more than 3, and the function we use negative when the y is less than 3. So therefore, this modulus function, when we more than 3, means 3 to 5, we use y minus 3. More than 3, we use positive 1. If you less than 3, we use a negative 1. So negative m y minus 3. So therefore, simplify your function. Lastly, actually it will be m between 0 and 2. And then negative function start from 2 until 3. And then positive function start from 3 until 5. Then only we can solve the question using the function. So as long as your modulus function you didn't simplify, you can't do this. Alright, so for question A, we want to identify the missing value m here is 2 over 9. So for small f here, small f represent probability. So in continuous random variable, total probability suppose equals to 1. Then in continuous means probability is represented by the area under the graph equals to 1. So we have 3 regions in finding this area, starting from integrate 0 to 2 for m respect to y. Here is continuous random variable y, so we integrate respect to y. Then continue for this and this, plus 2 to 3 for negative m dy, then plus 3 to 5 for positive function. Then their area have to be equals to 1. Alright, so to integrate this, take out your constant, integrate 1, it will give you y. Integrate y, give you power plus 1 over new power. Integrate constant, negative 3y. Then and we factorize the constant, integrate y, power plus 1 over new power. Integrate constant, we get 3y. Then we substitute upper limit minus lower limit. Substitute 2, it will be 2n minus 0. So here 9 over 2 minus 9 minus 4 over 2 minus 6. This one 25 over 2 minus 15, substitute 5 minus 3. Then we figure out how many m here. So how many m here? Negative half? Negative, negative, positive. Is it? Then here how many m? 2. So total 9 over 2m. So m is 2/9. Alright, so we've shown that. Means your function here all can be updated. M is 2/9. Then for question B, finding its probability means finding its area also. Probability in between 2 and 4. So we identify the area, where's the 2 until 4. So start from here, 2 until 4. 4 is here. So your region will be 2 to 3 and then 3 to 4. Different function. Alright, so you cannot integrate, start from 2 up to 4 directly. 2 to 3, negative function. 3 to 4, positive function. So you follow through. Alright. So to integrate this, same procedure, constant we factorize out, then we integrate power plus 1 over new power, upper limit 3, lower limit 2. Continue, substitute the upper limit minus lower limit. Alright, can you get this? 2/9? Yes. Then for part B1, B2, the question comes with modulus. So when the question comes with modulus, we solve the modulus first. Probability modulus x minus 3 less than 2. So in continuous, whether you got equal or not, it really will not interrupt our working. So you got equal or not equal, we will still integrate from the value to the value. We got continuous here, so we will not skip the number. So for this, open the modulus less than. So your modulus definition less than. When you open this, there will be -1 less than the modulus function and then less than 1. So by using the definition, the definition of the modulus will be -2 less than y minus 3, open the modulus, then less than 2. Simplify first, we identify. So y is in between, plus back 3, 1 until 5. Alright, so we figure out the region, start from 1, which is here, until 5. So we are involving so many of region, which is 1 until 2, 2 until 3, then 3 until 5. So why not we just take overall of the probability is 1, we minus off 0 until 1. When you want to take your region, start from 1 until 5, actually you take a lot of the area already, majority of the area already. So why not just minus the region that we don't want? It will be more faster for us to calculate. Alright? Or not, you need to integrate 1 until 2, this function. 2 until 3, this function. 3 until 5, this function. 3 integration to go. So do it reversely. 1 minus the region we don't want, which is 0 until 1 for the function 2 over 9. Integrate constant, we get 1y. Then substitute upper limit 1 minus lower limit. Then you can get 7 over 9. So another alternative we can accept where you integrate start from 1 until 2 plus 2 until 3 plus 3 until 5. So this is another alternative we can accept, but I will choose this because calculation will be more easier, more shorter time we use here.